In this video, I'm going to give a little introduction to the binomial model and kind of break down the calculation that we're doing. However, when we get to kind of the formula for it and the calculation part, we are going to rely on technology for this section, especially GeoGebra, which is a really nice organization and visual attached to it of finding these calculations. It's a little clearer than just plugging into a formula and solving. But to give you an idea of what we're doing when we're calculating probabilities with the binomial model. So the binomial model is a specific model that calculates probabilities in a specific way because of the setup of the problem. Now, the setup of the problem is something called a Bernoulli trial. Now, a Bernoulli trial is when we repeat a process over and over. So we're repeating this experiment, and with that experiment, we're going to have these set outcomes. Now, with each outcome, there's only two possibilities. So that's the bi part of binomial, is there's only two possible outcomes, success versus failure. Now, in terms of what success and which is success and which is failure in these cases, success is always going to line up with what we're looking for. Meaning, while in English, we have these kind of positive and negative connotations with success, failure, and that's not necessarily what we do here. Success is going to match up with what we're looking for, and the failure is going to be that opposite scenario. So there's even going to be times we'll look at an example together where we're looking for microchips to fail. So that probability of the microchip malfunctioning is actually our success because that lines up with what we're looking for. So we'll talk about that more. Basically, it'll either match what we're looking for or not. With that, we're going to have some notation. Little p, lowercase p, is going to represent the probability of success. And with that, we'll also have lowercase q, which will represent the probability of failure. Now, if these are only two options, then that means that they should add up to 1, which means they should be complements of each other. Together, these should represent all the possibilities in our sample space. So most often, they'll give you this probability of success. So to find your probability of failure, you'll just take 1 minus that probability of success. Some other notation that we'll have here is that with Bernoulli trials, we're repeating trials over and over, and they're going to tell you how many times to repeat that process. And with that, we use our sample space notation, n, but in this case, it's kind of specific to the number of trials that we're looking at. So when we have this probability of success and we're repeating this number of trials, that probability of success should always stay the same. For each trial, it shouldn't be changing trial to trial. So with that, we should have independence, that our probability stays the same after, the result of one trial isn't going to change the probability of success for the next. Another way that we might see independence is with that 10% condition, that idea of sampling from less than 10% of our population. So with the Bernoulli trial, and we've seen a few of these actually already, it's just when we look for probability, it was for a specific sequence of events, but two possible outcomes, and those probabilities stay the same trial to trial. So let's look at an example with calculations that we've actually already done, or we have the tools to solve with. So we have a basketball player who makes about 82% of her free throws, and what we're going to do is assume that her shots are independent. Meaning that 82%, that's her set probability of success. It's not going to change. And then we want to find the probability of these two scenarios here. So in terms of our notation, probability of success is 0.82. If we wanted our probability of failure, which would represent her missing her free throw, we would take 1 minus that 0.82, which is a 0.18. Now these questions here will be a little bit different and not quite a Bernoulli trial because we aren't going to have really a number of trials that we're looking at, though they are going to tell us about a specific sequence of events. So when we do this, we're going to use the multiplication rule here. We're going to talk about seeing results of these successive trials multiplication rule. So with this first question, they say that she makes the first free throw on the 4th attempt. So what that's going to require is that she's going to have to miss, and then miss again, and then miss on the 3rd attempt, but then she'll make it on the 4th attempt. So this wording of miss and then miss and then miss, that's going to bring through our multiplication rule. So our probability of failure, so the probability of missing is 18%. So we'll have 0.18, 0.18, 0.18, and then a 0.82 to get a 0.0048. So this isn't anything new here, just applying our multiplication rule, but the key is that it's a specific sequence of events here. They're telling us exactly how it has to occur. Now, something I want to do with this next one, this idea of making the first free throw on the 12th attempt, well, I'm going to have missing the free throw 11 times, and then she'll make it on the 12th. So what I want to introduce here is our idea of exponents, which maybe we haven't seen very much this term, but like for this case up here, I could have rewritten this in a shorter form of that this would be that probability of failure, and we'd have an exponent of 3 times our probability of success. And that only happens once. And if there isn't an exponent, you can imagine that kind of, there's a 1 there. We just don't write it each time because it's kind of redundant. But what you can see with this setup here is that the exponents tell you how many failures you're having and how many successes you're having. So with the shortened form, it can be kind of nice to get a translation in words of what we're looking for. So if I want to do this for our second example of missing 11 free throws and then making the 12th attempt, what this would look like is having our probability of failure, and we'd see that 11 times in a row, and then on that 12th attempt, success. And if we plug that into the calculator, it's going to come out to be about 0, because this is a very specific sequence of events. And also what you want to keep in mind with these questions, because we're going to look at a lot of examples dealing with this scenario of this basketball player, is that she has a really high success rate. We expect her to make almost all of her free throws, like 82% chance of a success. So for her to miss 11 in a row is really difficult for her to do because she's so good at basketball. So with this setup, we can see the exponents and how they relate to this scenario. So both of those were specific sequence of events, and what we're going to do in binomial is make it not specific. We're going to say there's going to be a certain number of trials. What's the probability of seeing a certain number of successes? Instead of saying exactly when the success occurs, like we see in part A and B, like they're saying when she makes that free throw, we're just going to say in general, what's the probability of seeing her make a certain number of free throws? So we're going to kind of go back to part A above where it was the scenario of missing 3 and then making it on the 4th attempt. What if we just say she's shooting the ball 4 times? So shooting the ball 4 times, what's the probability she makes exactly 1 basket in those first 4 attempts? So it doesn't have to be this specific scenario of part A of her making it on the 4th attempt. She could have made it on the 1st. She could have made it on the 2nd or the 3rd or the 4th. We'd have these different scenarios coming through, so the probability would change because there's different ways that can happen. So let's see how this formula comes through. So she's going to have 4 attempts, so that'll make our number of trials 4, 0.82 probability of success, 0.18 probability of failure. And what we want to do is just outline how many ways can this occur? How many ways can she make 1 basket out of her first 4 attempts? So let's say she could make the first shot, or she could make the second shot, or she could make the 3rd, or she could make the 4th. So what this would look like, her making the first shot would mean she makes it and then misses her next 3. So each time she's shooting the ball 4 times, it's just a matter of when does she make it and then for which baskets does she fail. If she made it on the second shot, what that would look like is missing and then making it, and then miss, and then miss again. Making it on the third shot, missing, and then missing, and then she makes it, and then she misses again. And this making it on the fourth shot is what we found in part A up above there, is that she misses, 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 and then makes it. So these are the different ways that this can happen to match this idea of making exactly one basket in the first 4 attempts. She makes it on the first, or the second, or the third, or the fourth. And if you notice that word that I'm using to connect those, that word or, means in terms of a calculation, what we're going to do is add those up. So before I add them up, what I'm going to do is change the notation a little bit. So like this first shot here, I'm going to change it to exponent notation. So this would be the same thing as having 0.82 once times 0.18 cubed. If I change the second one, it's actually going to be the same thing. With multiplication, you can move things around in any order as long as it's just through the multiplication. So what I can do is rearrange that, and we'd have 0.82 once and 0.18 3 times. Same thing with the third shot one. We'd have 0.82 once, 0.18 cubed. And this would be 0.82 once times 0.18 cubed. The idea being, again, to go back to what we're looking for, is this probability that she made exactly one basket in her first 4 attempts. Each of those is the idea of making the basket once, missing 3 times to fill up those 4 attempts. It's just we have to think in terms of these different scenarios here to think about how could that occur? How many different ways can this happen? So that when I get to this stage of adding them up, I'm adding the same thing to itself 4 times. So what this would look like in terms of a long calculation is 4 times having one of these 0.82s times this 0.18 cubed. And this right here is getting at the binomial formula, which again we're going to avoid. We're going to use GeoGebra, but I want you to see the breakdown of where these probabilities are coming from. So to answer this scenario of what if we wanted to find this exactly one basket in first 4 attempts, if you see the breakdown here, it's that to have that, we would need to figure out the numbers of failures. So what we're doing here is taking our probability of failure and raising it to the exponent of number of times we have to fail to fit that scenario. And then this right here, if we think about that exponent of 1 right there, is that this will be our number of successes, which would be taking our probability of success and raising it to the power of number of successes. Now the tricky part is this one right here. This number coming through is describing the number of ways this can occur. So in our case, it was that there were 4 possibilities to have 1 success out of 4 attempts. This calculation comes from something called a combination. If you see notation for like NCR or NR like that, those are combinations, and it's used for calculating how many combinations can we have. In this case, how many ways can we choose one thing from 4 items. And this calculation is what we're going to avoid, and we're just going to jump into GeoGebra. But this is what's happening in the background. It's taking into account how many successes and how many failures we need, along with how many different ways can this occur, which bumps up the calculation. So if we throw this into a calculator, we get 0.0191 out, which would just mean there is a 1.91% chance she makes exactly 1 free throw in 4 attempts. So there's no specific sequence of events here. It's more vague in terms of how it occurs. If it's a specific sequence of events, we use the tools up here. If it's not specific, then we're going to use the binomial formula, But again, for binomial, instead of doing this, we're going to GeoGebra, which I'll show you in the next video.